Alright, hello everybody to the final workshop for the Mini Gaming PCB workshop plan. As always, I am Daniel Alexak, the CVU IEEE president, and in this last workshop we're going to be teaching the students how to use Fusion 360. So what we're using this for in this workshop is to make a case for the back of the PCB, and this is going to help ensure that they don't short the buttons in the back, that it's a lot more comfortable in the hand, and overall it just looks a lot nicer. So getting into this workshop, you're going to need to ensure that the students have Fusion 360 installed. This is the same as Eagle, where it's a CAD software, so it's free with their educational license. And then also optionally Ultimaker Kira. Ultimaker Kira is for actually 3D printing your parts, so it is up to your discretion if you would like to show the students how to do this part. But we have it built into these slides anyways, and I'll be showing you how to do it just in case. So starting off these slides, we have what is a 3D design. Essentially, a 3D design, or also known as CAD, is where you're taking your software, in this case Fusion 360, and you're making a 2D object come to life. You're making it three-dimensional. And what this is allowing you to do is either put it into other softwares for usage, or 3D print it, like how we've been doing in this workshop. And so here's a few reasons why we do 3D designs. Every single field in engineering uses 3D designing, whether they be for 3D printing, whether that be for CNC, whether that be for anything in between. Everything uses 3D designs, and so you're going to want to make sure the students have some sort of knowledge on this, because it is incredibly important to get into engineering. Everybody has done it at some point during their time at CVU. So getting into Fusion 360, ensuring that everybody has it installed. It doesn't have the same problem as Eagle, where it has any dead files, so they should just be able to open it right up, sign in with their CAD email, and open it up immediately. This one is going to be a lot more hands-on, so you're going to want to just, after every single slide, you're going to want to hop over to Fusion 360 like I will, to show you how to use the software, and essentially just kind of let the students learn, let them do their own thing. Let them try to understand how to read an orthographic projection, how to figure out the UI, everything in between. So this is the first part that we want them making. It's just a very basic square that has a circle in it. So I'm going to hop over. This is probably going to be a much quicker workshop, just because this is all very repetitive. Over here, we're just making a lot of different parts, very hands-on. So this is what you're going to see when you open Fusion 360. The basics of what you need to know, because there's a lot of things here like Eagle. What you do is you create a sketch, and from a sketch you extrude it or change it in some way. So I'm going to create a sketch on the flat facing surface. I'm going to create a 2-point rectangle and click it here and do a 10 by 10 millimeter, because hopping back over to our PowerPoint, oh sorry, this is 20. I'm going to make a 20 by 20. And so you see there that I'm just making a sketch. If I click finish sketch, it doesn't exist. It doesn't do anything. If I rotate this, if I hold shift and then middle mouse click, by the way, this is going to be something very important to actually teach the students, is how to navigate this. They're definitely going to want a mouse for this. This just exists here in free space, and this does not have any actual body to it. It's just a sketch. Now the way you make this pop out, if I see it's 5 millimeters wide, is click the extrude button, or you can click E. And what this will do, it highlight a surface that you click on, and you can see if I press 5 millimeters and hit enter, boom, it's now 5 millimeters wide. So you just made a 20 by 20 by 5 millimeter wide object. And so the way going from here to make that circle in the middle is to create another sketch. I'm going to click on top of this box, and there's something called construction lines. This is the very basics that I'm going to be showing you, but what you're going to want to do is use a construction line and click line, go to about halfway through, which is 10 millimeters. And what this is doing is ensuring that the lines that you are creating here, these don't actually show up on your final part. These are simply just for you to actually use as a guide. So for example, I got to the middle of my box there to place this circle by just doing one line here, going to the middle, and one line up from that middle to the very middle point of the box. And so I'm going to now click on create a circle. I'm going to unhighlight construction line, And you'll see here what this allows me to do is now click on that middle point that I just made. That's why you want to use construction lines. And then so if I click 10 and hit enter, I will have just made a circle in the middle. But what can I do with this now, you ask? If I click on it and click extrude, instead of going up and creating something like this, what you can do with extrude as well is you can cut by going downwards through the object. You'll see it turns red. By cutting through it, you can see the operation actually changes when I do that, and I click OK. There you go. It is now cut through the middle of that object. So to highlight everything we just went through very quickly, create a sketch is the fundamental for everything. You need to create a sketch to draw onto your objects. You have all these different shapes and tools that you can use to create your sketches and make them for your purpose you need. And extruding is the fundamental. You can press E to do that. Extruding is the fundamental to getting your objects to exist. There's also different things like a fillet that you can do to bring in different sides. I believe some of the other ones actually utilize some of these other tools. But you're just going to want to show them the basics of this program. So the same thing will go when you show them this component. It's going to be the same exact process. You're going to click here. You're going to click on a plane. You're going to make a two-dimensional shape. You're going to click complete, extrude it. You're going to go up, and you're just going to continue to make the shape that we showed. So I'm not looking at it right now, but I think it looked something roughly like this, where you're adding things on top of each other, extruding upwards, and then you click on this side to be facing this part. Finish sketch, extrude, that face right there, pull it out, and there you go. I didn't look at the dimensions of that, but that's essentially what you'll be doing for every single one of these. This part is a little more complex because it has a lot more circles and cuts and fillets in it. So this one is up to your discretion if you want to do this. We do still recommend it though, because it's supposed to be one of the longer workshops. Yeah, that's the essentials of how to use Fusion 360. Very simple. Just remember your sketch, your extrude, and then your additional parts that you can do. So now, going on 3D printing, this is a part that is up to you if you want to show them, but I do recommend it to show them what you can do with these parts, is to export them on Fusion 360. So when you click on this tab, you'll see the export button. You're going to click over here and name your item. So I'm just going to name this a workshop part for now. And this isn't auto-selected, but it'll probably show up as this file or a 3MF file. But what you're going to do is scroll down to an STL file, click on the correct location that the students can be able to find it, and click export. What this will do is allow you to actually upload the part into Cura as an STL file. STL files are needed to be able to actually 3D print. It's just the format that the applications understand. So that's how you export a file. You can export these designs to an STL. It has to be an STL. And you can drag them into your app called Cura, and you can set these up for a 3D printer. So the way you do this is if you export your STL file, you're going to import it to Cura. Now, we already have this set up for the 3D printer that we use for our 3D printing, but you can do this with any example one. I'm using the Elegoo Neptune 3 Pro, but this is if they were to have their own printer. It would show up just like this. You would click non-printer, and then you would just go through here, non-network printer, and find the printer that they're using. So let's say they're using an Elegoo Neptune X. You click add there, and it'll show up now as this being the base plate. So the core of Cura is to import a file using that button up there, and you'll see your 3D object now exists on the build plate. You can see here, if I hold right click, you can see that this is now the view of what it looks like on your printer. This is how much space you have, and this is how big it'll be. If you click up here, these are all of your different options that you have. Now, I have this edited so I can see a lot more different settings. I recommend doing the same thing. If you go into settings, configure setting visibility, and then check all, be able to see all so you can see everything. So you can see all these different all these different settings if you want to show the students these. Here's how you add on your supports. Here's how you change how much infill it has. I'm just going to leave this all the same just for simplicity. But you can see this is where you change all of your settings. 3D printing is kind of a fine art where it takes a lot of different tweaking to be able to understand exactly what each print is going to need, where supports are needed, how much infill something needs, how fast it can go. Just really getting dialed in with your own printer. But regardless, when you have your object here, you can click on it, you can move it around, you can do whatever you want to it, you can rotate it if you so please. But the main core of it is you're going to be clicking this button down here, slice. And what this did, you can't see it unless you click preview, it's actually breaking down your component that you just built into piece by piece. You can see if I drag this, it will actually show piece by piece what it will look like when your printer is printing this, how it will tackle every single layer and what it'll look like. There's the infill there. You can see that's what it'll look like on this one layer. If I go down one level, you can see that's how it's going to fill in this layer. Essentially, this software is turning your 3D model into instructions for a 3D printer on where to extrude, how much to extrude, and how fast to be moving to actually get it into a 3D model. So a very simple display for the students. If you'd like to, you can export your own models that you make on here and then import them. Make sure you save them to a location that you can find easily. But that's how you're going to show the students how to do 3D printing. Very simple, very fun. There's a lot more in depth you can do with that. But again, we don't have the printers there in the workshop, so that's just kind of a bonus thing if you want to show them. Anyways, that's how you're going to be teaching the final workshop for the mini gaming PCB. We will have in our files here the 3D print for you to print. This is the PCB case that you will be utilizing. I don't know if that will load fast enough, but what you're going to be wanting to do is print out as many of these cases as there are students. This is built so you don't need any supports or anything. You should just be able to slice it, preview it, and then just print it. And it's a pretty fast print. You're going to want to mass print these, and these will be slipped around the PCB. So again, everything, if you need to refer it, will be back in the master file, so you can refer to this later. So yeah, thank you again for coming along with me on this workshop and explaining how to teach a student. And if you're unfamiliar with how to actually utilize any of these programs yourself, I hope you learned a little bit, and I hope you were very successful with teaching students. Thank you so much, and I appreciate your time.